Thank you for joining me. Welcome to TJ's Maths Clinic, my amazing viewers. We continue with our differential calculus. With us here is example 3 under differentiation from first principle. This is one of the methods of differentiation. We have up to 6 different methods of solving a problem under differentiation. Example 3, read. Find from first principle the derivative of 1 upon x squared plus 1 with respect to x. We are asked to find the derivative of this. The first thing for us to do is define this expression to be x. Let's write down to be y rather. Let's write down the solution. Let y equal 1 upon x squared plus 1. Let's call this equation 1. Very important. uh, Increase in this y now with respect to x, or increase in this y will be y plus delta y will be equals to 1 divided by increase in this x now will be, anywhere we see x, it will be increase in the x now will be x plus delta x because of this square, all square plus 1. Very important. Let's work on this to get equation 2. So this will now be y will now be equals to that's change in y rather. Change in y will be equals to 1 divided by, let's say expand this. If we expand this, we have x squared plus 2x delta x plus delta x all square plus 1 now will now be minus this y. Very important. So this will say to be our equation 2. So let's substitute equation 1 into equation 2 such that, let me clean here, such that we have delta y now will be equals to 1 divided by x squared plus 2x delta x plus delta x all square plus 1 minus, in place of y now, y is nothing but 1 divided by x squared plus 1. Very important. The next thing for us to do here, let's find the LCM. Let's find the LCM. Very important. Let's find the LCM of this expression. Let's find the LCM so that we can reduce it. You realize that we have x plus 1, x squared plus 1, then we have x squared plus 1 on the other side. Okay, so let's find the LCM and simplify. Of course, the LCM will be, the LCM now is nothing but x squared plus 1 into x squared plus 2x delta x plus delta x all square plus 1. This is said to be our LCM. Very important. So delta y now will be equals to, we use this LCM, we now say x squared plus 2x delta x. Delta x, of course, all square plus 1 into this will be left with this times 1. We'll have x squared plus 1 minus this, will remove this, will be left with the whole of this now. That will be x squared plus 2x delta x plus delta x all square plus 1 divided by the LCM x squared plus 1. We have the square bracket x squared plus 2x delta x plus delta x all square plus 1. Very important. Our aim is to find change in y with respect to x. Permit me to clean here so that we can work on that. Let's open the bracket in the numerator. Our change in y now will be x squared plus 1. This minus will distribute. We'll have minus x squared minus 2x delta x minus delta x all square, of course, minus 1, divided by the LCM x squared plus 1. We have our square bracket x squared plus 2x delta x plus delta x all square plus 1. We close the bracket. Very important. Observe in our numerator, this x squared will go, plus 1 minus 1 of course will be 0, such that we are left with delta y now will be equals to minus 2x delta x minus delta x all square divided by the LCM x squared plus 1. We have the square bracket x squared plus 2x delta x plus delta x all squared plus 1. We close the bracket. Very important. What can we do from here? Let's let's divide each term by delta x. Let's divide both sides, left and right, by delta x. So what will be our delta x now? Very important. Therefore, at this point, changing y now with respect to changing x will be minus 2x delta x now minus delta x all squared divided by the LCM x squared plus 1. We have the square bracket x squared plus 2x delta x plus delta x all squared plus 1. We close the bracket divided by delta x. We are dividing through by delta x. Very important. Okay, so what's the next thing to do? We can change this division to be multiplication. It means we multiply this by delta x in this manner. It's the same thing. Instead of dividing, we can divide it by 1 out of delta x. Very important. Okay, so let's see what we can we split this? Yes, let's split and see what we can get. So, changing y now with respect to x will now be equals to, let's split this. This is the same thing as minus delta x. We can factor delta x here in our numerator such that we have delta x out into 2x. If we factor minus delta x, that will be plus delta x now. We close the bracket divided by so that we can cancel out, so that divided by x squared plus 1 square bracket x squared plus 2x delta x plus delta x all squared plus 1. We close it, multiplied by 1 divided by delta, so that we can remove this. Very important. Changing y now with respect to changing x would be minus 2x plus delta x divided by x squared plus 1. Then we have x squared plus 2x delta x plus delta x all squared plus 1. We close the bracket. Very important. At this point, let's split and see what we can get. Very important. Or we can take the limit here such that anywhere we see delta x, we plug in 0. So therefore, the limit now, let me take it here. The limit as delta x tends to 0, the limit now as delta x approaches 0 of changing y with respect to x now will be, anywhere we see delta x, we substitute 0. So this will be minus 2x plus 0 divided by x squared plus 1. We have our square bracket, x squared plus 2x. In place of this delta x, we put 0 plus 0 all square, then plus 1. That's in place of this delta x now, it will be 0 all square. What are we going to have? Hence now, finally, this would be, let's resolve this, it will be minus 2x in our numerator because this is 0, of course. This will be 0, this will be 0. Be left with divided by x squared plus 1. Then in the other bracket, we have x squared, then plus 1. Very important. This is now our delta y divided by delta x. Hence, finally now, hence, we can conclude, hence, changing y now with respect to x will be minus 2x divided by, we have 2 of these. So we can write it as x squared plus 1 all squared. This is said to be the derivative of this function from first principle. Thank you for watching. Do share this to your learned colleagues. See you in my next video with example 4.